Find each limit or value using the provided graph and circle the limits that describe end behavior. The first one says the limit as x approaches -2 from the left, f of x approaches what? So here's -2. So as x approaches -2 from the left, f of x approaches 3. And as f of x approaches -2 from the right, f of x also approaches 3, which means the limit as x approaches -2, f of x approaches 3, because the left hand and right hand limit are the same. And f of -2 is 3. That point is -2, 3. The limit as x approaches 1 from the left side, let's see where 1 is. Here's 1. So from the left side, the graph as x approaches 1 is going to be 1. And the limit as x approaches 1 from the right side is going to be, as f of x approaches, it's going to be -1. So the limit as x approaches 1 from the right side, f of x approaches -1. And these two limits are not the same, so the limit as x approaches 1, f of x does not exist. And f of 1 is equal to -1, because here we have the included value and here is an open circle. So our answer for number 8 is -1. Okay, let's look at our next set. The limit as x approaches 3 from the left. So let's find 3. Here's 3. So the limit as x approaches 3 from the left. So 3 from the left looks like it comes to 0. And 3 from the right looks like also 0. So the limit as x approaches 3, f of x approaches 0. And f of 3 is also 0. That point there is 3, 0. Our next one says the limit as x approaches infinity, f of x approaches what? So the limit as x approaches infinity, f of x approaches, looks like it's going to cap out here, so perhaps an asymptote at 0. So it looks like our limit is going to be 0. The limit as x approaches 4 from the left, so where's 4? Let's see where 4 is. 4 is right here. So the limit as x approaches 4 from the left. So here's 4 from the left. It looks like it's going to keep going up, which means that our limit is infinity. It never actually touches 4. There is an asymptote here. So it's going to be infinity. And number 15, the limit as x approaches 4 from the right, f of x approaches what? So let's see. Again, it just keeps going straight up and it never touches 4 because of that asymptote. So this is also infinity. So the limit as x approaches 4, f of x approaches infinity. However, f at 4 is actually undefined because of that asymptote. There is no value of y that the graph will cross the asymptote, right? The graph is never going to cross that asymptote. So our value at 4 is undefined. And number 18, the limit as x approaches 7, f of x approaches something. So now in order to find our whole number where there's no, where if it's asking if it's coming from the left or the right, when we have to, when it asks for something like this, we have to look at our left and right hand limits. So let's take a look at that. So we have, as x approaches 7 here from the left, and as x approaches 7 from the right, we've got it at 1, it looks like. And they both come at the same point, so it's at 1. And f of 7, right, this point here is 7, 1. F of 7 is also 1. And our last one, the limit as x approaches negative infinity. Here's negative infinity. Our f of x approaches 1, it looks like. It doesn't even get to 0. So let me draw that one again. Because if you look at our arrow, it kind of goes like this. So it looks like we've got an asymptote here on this side of our graph. So the limit as x approaches negative infinity, f of x approaches 1. Now remember in our directions it said circle the limits that describe end behavior. And end behavior is finding the limit. So we are going to circle this one here, number 3. We are also going to circle number 7. We are also going to circle number 11 and 13, as well as 16 and 18 and 20. So all of these that are circled do not ask for right hand or left hand, but rather both, right? You have to look at both, just like in 18 where we had to look at the right hand and the left hand limit in order to find the limit as x approaches 7. So all the ones that we circled do not ask for left hand or right hand limits, but rather the limit of the whole number on that point on the graph. Okay, and here's a little clip from, it's a little movie image, right, from Mean Girls. Just like that clip we saw yesterday about the limit not existing. So it says, using your answers above, identify the conditions in which a limit does not exist. I want you to pause the video here and take a minute to write down some ideas. Okay, so let's take a look at it. Here's one of the things that I wrote. When the right hand and left hand limits do not match or do not equal each other, then the limit does not exist. I hope you came up with at least one other one. So for part C, it says, at what x values is the graph discontinuous, meaning not continuous? And what is happening with the limits at those particular x values? So let's look at our graph where it's not continuous. Let's see. That means, not continuous means that our limit does not exist, as well as this, our asymptote here. So at x equals 4, and where did our limit not exist? Our limit did not exist at 1 either, which means at x equals 1, our limit did not exist because left-hand limit and right-hand limit are not equal. And at x equals 4, we have an asymptote, which means that our limit is infinity. It could also have been negative infinity, it just depends on your graph, right? It could have also been going downwards if it wanted to.